Hello, Numerade. Okay, we're doing number 13, but it's based on number 3. So number 3, we're given this stochastic matrix, as you see described right there. And we played around with what happens if we start with 20% ill on Monday, what happens on Tuesday and Wednesday for the ills, and what if we start with 100% well on Monday, what happens to the wells on Tuesday and Wednesday. Okay, but now question 13 is this. Let's see, I'm just going to copy this. And it's on page 263, actually. Let me just separate my output a little bit. So this is question 13. They want you to find the steady state vector. So what we're going to do is going to apply. Okay, just a minute.
What are you doing?
I'm recording.
You're still recording?
Okay, stop. Okay, so regardless of what matrix you start off with, let's say we start with 50% well and 50% ill, right? It's a probabilistic probabilistic vector, so it has to add up to 100%. Okay, there we go. Let's get rid of this. Let's see what happens if we apply m several times. That's one way to get the steady state vector if it exists. So how about for n in range 1 to 10? That's what we get. And what we're going to do is just apply m again and again and again. So m of x0 is x1, m of x1 is x2, m times x2 is x3. Well, that's just powers of m times x0, isn't it? So I'm going to say, let's show m to the n times x0. And again, the question was also, does it matter what x0 starts at? Do you still get the same result? We'll change up x0 and see what happens. It shouldn't, right? So I'm going to say m to the n times x0. Let's make this a little more fancy. Let's print out the power that we're talking about, the x1 that we're talking about. So let's put a quote there, comma, a comma there, and a quote. All right, let's see what we get. So this is question 13. By the way, there's the output for A, setting up the stochastic matrix. There's the output B, analyzing the ills, and C, analyzing the wells. Okay, so if we start with 50-50, and so we get x1 is 70-30, x2 is 80-20, and so forth. Now, is there a limit? Well, it looks like it might be going to 0.9 and 0.1. So what's the long-term effect? In the ills, what's the question? Looks like 10%. Let's see if that's true. Let's throw in some bigger exponents just to make sure. How about from 10 to 100? Let's not print them all out. Let's print out every 10. Alrighty, so let's see, 0.89, 0.1, blah, 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 is getting really, really, really close to 0.9 and 0.1, I think. So 10% ills in long term. Let's go crazy. How about 100 to 1,000? And let's print out every 100, every 100th one. Alrighty, so to the 100th power, we get basically the same thing. To the 500th power, same thing. There was some crazy round-off error at the end there, but it's basically 0.9, 90% well and 10% ill in the long term. Now, does it matter if we change x0? Let's see. Let's make x0, let's start with 100%. Well, let's see if we get the same thing. And question 13. So starting with 100% well and 0 ill, still seems to be going to 0.9 and 0.1, so 10% ill in the long term. And how about if we start off with, 0% well and 100% ill? Does that matter? Let's see, question 13. Nope, don't think so. All right, looks good. So that's your answer. Okay, Numerade, hope that was helpful. Good luck with your homework. There's question 13 right there. That's it. You wanted to look at question 3? I have a separate video. You can take a look at that. Here's the output for question 13 right here. So the final result is 10% ill in the long term. Okay, good luck with your homework, guys.